We move ahead to the last module of electrons and photons, and in this module we are going to solve MCQs based on every concept that we have studied in this chapter. So moving ahead to solve the first MCQ, it says that when a light of wavelength 3600 nanometer falls on a photosensitive plate, the photoelectrons are emitted. However, for another photoelectric emitter, the light of 6000 nanometer is sufficient to produce photo emission. So I have two wavelengths which are producing photo emissions. Can I say these wavelengths are actually the threshold wavelengths which are provided? What is asked in the question? They are asking us to find out the ratio of work function of the two emitters. The options which are given to us are 5:2, 5:4, 5:3 and 3:6 respectively. Now how do we start solving this problem? When I say I have the work function that needs to be determined, let us first write down what is given to us. Lambda naught 1, that is the first threshold wavelength, is given as 3600 nanometer. Lambda naught 2 is given as 6000 nanometer. And I know that work function is given by hc by lambda naught. But students, we all know that hc is constant. So can I say work function is inversely proportional to lambda naught? So using this relation while we solve the problem, I can write work function 1 upon work function 2 will come out to be lambda naught 2 upon lambda naught 1. Can I say lambda naught 2, I have the value, lambda naught 1, I have the value. When I substitute them, I get the answer as 10 upon 6, which on further dividing, I get it as 5:3. So this, students, was a very simple problem. Moving ahead to the next problem. Next problem says that the work function of a given metal is 4 electron volt. What should be the wavelength of the incident radiation for the photo emission of photoelectrons of zero velocity? Now these electrons do not have velocity and we need to find out the wavelength. What is provided to us is only the photoelectric work function. The options given to us are 2500, 3100, 3500 and 3800 respectively. When I solve this problem, I know that work function is given to me, that is 4 electron volt. The wavelength is unknown that I need to find out. But I know the velocity of the photoelectron is 0. Since the velocity of the photoelectron is 0, the kinetic energy must also be 0. That means all the energy is actually used in the terms of work function. But we know energy is hc by lambda. So can I say hc by lambda is equal to W naught? So if I need to find out the wavelength lambda will be hc upon W naught. On substituting all the values, I get the equation like this. I have substituted the value of h, c, W naught. And when I solve this, I get the final answer as 3.093 into 10 to the power minus 7 meter, which corresponds most closely to 3100 Armstrong unit. So students, moving ahead to the next problem. In this problem, what is given to us that there are photons which have energy 5 electron volt which falls on a photosensitive surface. That means energy is given to you. The maximum kinetic energy of the photoelectrons emitted from the surface is 2.5 electron volt. Now they are asking us the stopping potential, and there are options which are given to us, that is 5 volt, 2.5 volt, 7.5 volt and 1 volt. Now if there is kinetic energy that is given to you, we know that Ke max is 2.5 electron volt. But we also know that Ke max is EVS, which is actually 2.5 volt. Now I know that 2.5 electron volt can be written as 2.5 into 1.6 into 10 to the power minus 19. So can I say alone Vs will come out to be 2.5 volt. So that is how we solve a simple problem based on the kinetic energy. We move ahead to the next problem. In this problem, it is given that sodium and copper have the work function 2.3 electron volt and 4.5 electron volt. The ratio of their corresponding threshold wavelength will be given by That means they have given us work function and they are asking what is the threshold wavelength. Now I know these are the options which are given to me, that is 2:1, 1:2, square root of 2:1 and 1:4. Now students, how will we go ahead about this problem? We assume the sodium to be of the case 1, so the work function in the first case is 2.3 electron volt. In the second case, the work function, that is for copper, it is 4.5 electron volt. Now I want the ratio of the threshold wavelength. That means I want lambda naught 1 divided by lambda naught 2. According to the relation, I know that work function is inversely proportional to the threshold wavelength. Since work function is inversely proportional to the threshold wavelength, W01 upon W02 will be equal to lambda naught 2 upon lambda naught 1. When they take that in ratio, that will come out to be 2.3 divided by 4.5. And when we take the ratio, this ratio actually comes out to be 4.5 divided by 2.3 for lambda naught 1 upon lambda naught 2. And when we solve this, the answer comes out to be 2. So their ratio is 2. So students, with the help of this module, we studied the problems which are based or mixed on all the concepts. Thank you.